Hi, it's Mrs. We want our numbers to be. So how many numbers or how many digits after the decimal point do we typically want to use? Well, let's think about pi. As you know, pi is a non-repeating, non-ending decimal number, 3.14159, etc. I've got about 1,000 digits listed there for you. And you can see that is a huge amount of numbers. Would you want to add that number to another number? I wouldn't. I wouldn't even want to punch all that into a calculator. In fact, it was kind of a pain to just copy and paste it into this presentation. It's big. It's cumbersome. That's why we typically use 3.14. Generally, you're going to see 2 digits after the decimal, unless you have a longer number in the math problem or you're specifically asked to do something different. Sometimes you'll be asked to use 3 digits or 5 digits after the decimal. And in those cases, that's what you'll need to do. Anyway, that's why we typically use 3.14 for pi. It gives us a good amount of precision without being too bulky or cumbersome to work with. You have. In this case, if we're just adding whole numbers, 15 plus 23, we would get 38. There's no need for putting the decimal point and the zeros after it because it's just a whole number problem. Now in this problem, we have 13.1 times 11. And you can see I've done the multiplication part, but I haven't placed my decimal yet. When we're multiplying with decimals, we just can count or swoop out however many decimals there were up in one of the factors, and then we swoop those back in to the product at the bottom. So in this case, the multiplication problem itself determines how many numbers are after the decimal. If you had a problem like 1.31 times 1.1, you can see in total there are 3 numbers after the decimals in the factors, which means we've got to go in 3 swoops in our answer. Okay, conventionally, we're going to go to the hundredths place. So when you have a number like 2/7 and you're turning it into a decimal, as you know, we're going to do our division. And you can see I've gone out to the 3rd digit here. I've got a 5 left over down at the very bottom. My next step is going to be to bring down a 0 and keep going and keep going. So I've done 3 more places after the decimal, and I'm still going. So now I'm going to look at my thousandths place. In this case, it's a 5, and I've circled it for you. And that's going to be my decision number. That number helps me decide if I should raise or stay on the 8. In this case, we're going to raise. So we would say that 2/7 is equivalent to 0.29. Sometimes you'll be asked to round to a specific place. When you are asked to round to a specific place, sometimes this means you'll need to use extra zeros. So if your answer for something is 7/10, 0.7, but you are asked to round or show your work to the thousandths place, you will want to write 0. So that's pretty much the end. Now we're going to do some more fraction to decimal problems, and you're going to be rounding your answer to the hundredths place. This is going to come in very helpful when we start comparing and ordering fractions and decimals, because you'll be a pro at doing your fraction to decimal conversion.